in a couple of seconds. I've now had the permission to record this webinar. I think it started right now.
Okay.
And did a small introduction. So please, you can start, and also perhaps a small introduction from yourself.
Okay. Hello. So I am Octavian, and I'm actually living in Munich, but I am right now at my home office because of quarantine issues, let's say it that way. So I am placed in quarantine for 2 weeks, and that's why, unfortunately, I'm not able to show you the machine itself. But we will focus on the offline station, and you will see everything you need to see from my PC. So I am working as an application engineer for Micronic and taking care especially about the optical inspection product, the VIT product, that's including the AOI and the SPI. And let me just share my screen. Okay. Okay. Good. And I will turn off my camera just to have a better connection, if that's okay for you. So as I said earlier, we'll focus 100% on the offline programming station, and we will be talking about Library Pro. Library Pro, it's a very powerful function, and we have some customer using it. But what we recognize that not all of the customer, they are aware of this powerful tool. And this function, it's available for you in the machine as well, and also on the offline programming station. And it's existing in your software already, and it's free of charge. So it will come for every software you are having installed. It will be available all the time. And why is this function so important? Because we know that most of the time that we spend on the AOI, it's actually, let's say, programming, changing parameter, defining new packages, and so on. And I just have here just quick images about different SO8. And we can see that this package can be different from supplier to supplier, but not only the package, the component itself, but also the board can be different from your product to product. Here we have different nuances of green, but you can have also maybe dark PCBs or blue PCBs. So we need the way how to handle these variances. And our solution for this problem, it's being able to record the images from the production. So normally, let's say in a traditional AOI, you will need to have a board with samples from each product, so then you can do optimization. But it's not very easy to keep a sample from each product that you have in your production, and then of course you have to stop the production, load the board, so it's a bit inconvenient working with physical boards. And to solve that problem, we are saving what we call the OIS. Maybe you are aware of the OIS, of course, and we can record this manually by a PCBI or in the production, or we can set up the review configuration. So if you go in the review configure, we have something called OIS export. And if we activate this function, the review station will automatically save the OIS in a different location defined by you based on the operator classification. So the false call will be sorted out by the true calls. So you will have a different location. And then you can do optimizations based on these OISs that you save in different location, and you can improve your library. So there is no need to have real boards on the shelf. All is done based on the images. Okay. And going back to the offline programming station, I hope you are aware of this software. If not, you can ask some, let's say, questions at the end. Here, when we pick up a model family, let's open this SO8. We can, of course, select the path where we store our images. You can have multiple paths. And when we press test tolerance, we will get the result for each image in our, let's say, image database. And then...
Ian, sorry to interrupt you. we at TVP don't have VI AOIs. So don't assume that we know where something is, and please explain a bit more of what you're doing and why you're doing. Because we have Kuyung machines and not VI.
Yeah, okay. I'm actually sorry for that. We should have made that clear in the beginning. So I was expecting this webinar to be a bit more focused on the existing customer. So this week.
No,
yes.
the idea behind this is that everybody can learn from what you can, and maybe that we in the future will buy a VI. So it's an open thing.
Right. So this week, in the beginning of the week, we had actually another webinar where we presented all, let's say more or less all the function. Did you attend that webinar?
Nope.
Okay. So I will try to give you a bit more context here so you understand what we do. But of course, to explain the full functionality, we will need another 1.5 hours. So this was intended to be.
Don't go too fast and just give it a bit more background, then it's fine for us.
Exactly. So I will try to give you a bit more context here so you understand. But I highly recommend you to join another webinar where we talk more in detail. So where I go step by step, maybe some machine details, some more algorithms and more 3D information. And that will be maybe 1 hour, something like that. We can organize something special for you. And I think that will be the best.
The idea for us was how to set up a library and check how you do things and what we can improve maybe and that sort of thing. So we don't need to know exactly how the machine works. It's more or less a general idea what you do.
Okay.
Don't expect us that we can follow everything.
For sure. So then before jumping into this OIS details, just let me give you some background. So this file OIS, it's something maybe what you can also save in your Koyang machine. It's the, I think it's called CBI or component-based image, something like that. And inside this file, you have all the 2D information and you have also all the 3D information. But the difference between us and let's say the competition is that you can load this into, let's say, your library and you can test all these images at once automatically. So you can keep as many images as you want, of course, as your space allows, as your hard disk allows, and then you can use that for optimization and fine tuning and keep to improve your library. Okay. And here, this is our library in this window. And this is the list with the packages from inside this, this program. And let's say on another machines, you will need to have maybe a board inside this AOI and then starts to do optimization. But in our case, you just open the package name, the model family, and then you can select your path with images. So you can have thousands of them. Let's say if you have a storage network or something, you can have thousands of images of samples. And when I press tolerance, all those images will be tested automatically. And from this point, you can do optimization. So let me activate also the 3D. So you see we have also the 3D here and also the 2D. So this all happens offline. There is no need to have the machine. And also you can test this against a very big amount of product range. And let me just open this. So then if I open it, then here I will be able to edit, for example, how I detect the body. So I want to detect the body in 3D and you can test, or how you inspect the solder joint. This is actually very interesting because we are seeing the solder profiler in 3D and we are making this nice chart of the joint in 3D and we can analyze this. So we can have different tolerances for height, width, convexity, the wet angle, length, and so on. And let's assume that if your user is changing something here, some parameters, how do we make sure that your changes are not affecting the other products? For example, what can happen? He make the tolerances too big, and then you will not detect defects anymore. Or he make them too tight, and then you have too many false calls. So how we prevent that in VIT? So after you do a change, you come back here, and all these images, they are tested automatically, or you can test them manually. And then you can see how are your changes affecting your products. Let's keep in mind that here we have images from, I don't know, the full production. I have here a small sample, but in your production you can have thousands of them. So then very easy, you can improve your library, and you can make sure that whatever change you apply, you are not making false calls, or you are not escaping any defect. So this is the main, let's say, purpose of the Library Pro, to optimize the library. And this is how we train our existing customer to optimize the existing library. So this is based on images. We are not, we don't care about the real product. We don't have to keep real products. And then the second biggest advantage of the Library Pro, on the column here, match, I hope you can see this, there is a column called match. And you see sometimes I have OK, sometimes an A, and here not OK. What that means? This OK, that means the error, in this case nothing, there is no error, is matching the expected result, which is nothing, no error. So that means it's a good component. Here again we have an OK field, and we have an error, we have a polarity error, and then expected results, it's a polarity error. So this Library Pro is comparing the expected result with the actual detected error, and then if the results are not matching, you will have a warning. And this expected result is coming from something what we call a certify image. So the user will have to certify an image, and if you right click on this image, image certification with VAT Manager. So then we are certifying this image as a good image. So now the software knows that this is acknowledged that it's a good image. Okay. And then we can exit, and we can do the same for, let's say, a defect. So NA, that means there is no certification available. And we see we have the error detected as polarity, but there is an NA for the expected result. So the software doesn't know exactly if this component is good or bad. So then the user can certify it. Okay, so I will choose the polarity, and now this image is certified as not good for polarity. And now the software is retesting again, and if the result is matching, error is polarity, expected result is polarity, final result it's okay. So the user is sure that whatever change he's done, it's matching. I have here an example prepared when it's not matching. So we see here it's highlighted in red, and it's a not okay, because the software is finding no error, surprisingly. The expected result, it's a bridge. So we certified this VBI in the past as a bridge defect. And also if we check the 3D and the 2D, we see indeed that there is a bridge there, but the software doesn't find it. So here is the moment when this function is really helping you, because if you have here, let's say 1000 images, you cannot just go to every image and check them to see it's real, it's not real. So you want the software to tell you the status, and then you can filter by the match, for example, and you will see the one who are not matching. And that means you have to investigate a bit what happened. Maybe your less experienced programmer did some settings that are not good, or maybe indeed it's a new challenging defect that you have to optimize better. So if I open this result, I can see that actually in the bridge output, there is no output. So the software is detecting the bridge, but is not giving it forward for a negative result. So probably, let's say, some less experienced programmer deleted this equation or forgot to place it in place. So I will just add it back. And now we see that the match is okay. We are finding a bridging error, and the expected result, it's a bridging error. So now I press OK. All the images are retested again automatically. And now the result is good. So we are expecting a bridging error, and we are detecting a bridging error. So this is how the software works, and this is the benefit that is giving to you. It's able to compare the expected results with the real error, and then you are making sure that your library is good. The same way you see now, I have a different sort of problem, let's say. You see again a not okay, and in this case is different. So the software is finding a bridging defect, but the expected result is good. There is nothing certified. So in this case, I come and I certify this. And this is also a bridging error here. And this is now certified as a bridging error. Okay. And now there is no more not okay. Everything is matching. That means our library, it's in a good condition. Everything is good. And of course, it's recommended that you are certifying as many images as possible, depending on your resources. But let's say the inconvenience here, what would be? So maybe you don't have the time to just manually check if each package. So now I'm checking this manually and I see this is okay, this is an A, and if something will be in red, I will spot it. But you don't want this. You don't want to spend time to check your programmers because it will take too much. So how we cover that? I will just cancel this. This library pro function, it has a feature called the Run Library Pro, and this will test automatically your complete library, and also it will provide you with a report. So here you will have to select the path where these images are, let's say, stored, and I will press OK. And now the software will automatically test all the packages inside our library based on the classified images, and he will give you this kind of reporting. And important here, in the green area, we have the confidence level. Right now, confidence level is 89%. What that means? That 89% from the packages are matching our expected results. So that means that 11% of them, they are not matching. So actually, this is not good. This should be, of course, all the time 100%. So we should detect every defect or have no false scores all the time. And then we have also the test coverage, which is 31%. That means from my whole library, which can be very big, I certified only 31% of the model families. So you still have to certify new images. You still have to improve this. And this is just quick information as percentage value to give you some insights. But then you have all the details as number, like total number of family, how many were tested, how many was excluded from the test, how many had no image. So we see we have 62 families and 43 has no certification. So you have to keep adding images for these 43 left packages. Okay, and so on. And here you have as well the list with all the packages, so you can visualize them. Or just a moment. Very, very important. You can also see the, let's say, chart, like the confidence level, for example, or the non-ratified family. That means non-ratified family, these two of them, CO603 and SO8, they have problems. That means the algorithm is not matching the expectation. So now you know for what packages to focus to improve your library by this report. So we have all this information by tabs. I will not go through very details because that's not the point now. And very important, we can also export this as an Excel file or as an HTML. So this is giving you total control of the library, and you as a supervisor, you don't have to go and manually test each package to see if it's good or not. You can run this library pro, you will get the report, and also you can save this report. And for example, during an audit, maybe if your customer is asking how you keep your library in control, how do you make sure that the changes that you are making will not generate more false call or more escapes? This is the way to prove it. and also provide a report. Okay, look, my confidence level, it's 100%. My test coverage level, it's 100%. My library is 100% under control. So this is the way to go. And as well, I just double clicked it here, and you can open that model family, and you can start the optimization right from here. So if something is not matching, like in this case, we say we are expecting a coplanarity issue, and this is a real coplanarity issue, but there is no error. So that means there is a problem. You have to look into this and fix this problem. Or again, this one is finding a joint problem, but there is nothing for the expected results. And if we have a look, we see this component has a good joint. So probably this is a false call. Again, you have to optimize it and make sure your library is in a good condition. So these are actually just example for my Library Pro test. We for sure can detect this component. So this defect, there is no problem in detecting it. I just change the tolerance in such a way that is good, just to prove how you can make sure that you don't have an escape in your production. Okay. So this was these were the main things that I wanted to tell you about the Library Pro and how we keep the library under control. But if you have any other issue, any other questions, please feel free to ask, and I can show you as many as you want.
Sorry, can I interrupt you?
Yes.
And regarding the footprints, is it also stored in the library or not?
The footprint, you mean the pad size or?
The pad size, yes.
We use the so we don't save that in the library, because of course the pad design is different from component to component. So also from product to product, you see here now I have a big pad design for this CO603, and then some other CO603 from another product, maybe it's a smaller pad design. So we can import the Gerber and we save it in the test file.
Okay.
So this is based on the program.
Yeah, but the test condition itself, because when you have a bigger pad size, then it will also affect your solder joint.
Yes, yeah. The profiler will be, of course, different when you have a different. Okay, let me show you. Maybe. So we go in chip and then we go in joint. And now, as I mentioned, we make this 3D profiler. And indeed, if you have maybe a small pad design, this will be smaller. So then you'll have a smaller joint, it will be a smaller length. So you can, of course, compensate by changing the tolerance. But our advantage, we are not so much dependent on the let's say Gerber size when we define our tolerance. So if I make this area just for purpose, let me also show you here. So if I make it very big, this will not affect us because the software will automatically test only the joint area. And you can control also the height in percentage from the body of the component, the width of the solder joint, and something that is not active here but very useful, convexity, inferior and superior. So you see now this dashed line on the chart, this is controlling the shape of the joint. So if the shape is not good, then this will fail. And as well, we can control the wet angle, the approach angle on the terminal, and also the length. So here may be the point of your case. If you have big pads and small pads, then if you want all of them to be in the same library and the same package, then maybe you'll have to reduce a bit this parameter.
Okay, thank you.
You are welcome. And the big advantage here, actually, because you can have all these images recorded, and then you can change your, let's say, settings, and you will see exactly the impact on the small pads and the big pads. And then you can decide what settings you should have. So here you'll have all the images. You see I have different types of capacitors. And will be very easy to take a decision because you'll have all the information tested at the same time. Okay. Is there any other question?
No, at the moment for us not.
Mm-hmm.
No.
If
What's the question?
mm-hmm.
No. Okay. Then I think we're going to wrap it up.
Mm-hmm. If you are interested in more details, because I was focused 100% on the library now, but there is so much more happening in our AOI, then contact Juan and we can organize one-to-one demo, maybe 1 hour, let's say, and I can show you more details about everything, how we make the program, how we inspect, I don't know, capacitor and SYC, and I don't know, any other details you may be interested in.
Yeah, we would like to join that.
Mm. Okay.
Okay, very good. Then, because when we we will make a new webinar agenda for next coming month, which we're going to communicate, and I think next week. So let us see also, Octavian, what we can do also for the other topics. But I think towards Ronald, right? If you want to have more in-depth presentation, then we will. We can organize this. Sorry, my camera. Then we can organize this, and then perhaps it's an idea that we make an agenda together of the things you would like to see. That we are making sure that we have a spot on presentation towards you.
Yeah.
It's all, of course, the idea of this webinar. So let's communicate this offline from this webinar. That we keep in contact, and I will contact you, Ronald, then the beginning of next week. Is that okay? And then we'll find a way to set this up. Yeah. Okay.
Yeah,
Good.
thank you.
Are there, I will go to Dutch again.
No
zijn er
problem.
nog vragen? Dan wil ik het graag hierbij afsluiten. Dan bedank ik jullie allemaal voor jullie bijdrage en uiteraard voor de deelname. En dan hopelijk tot de volgende keer. En iedereen een fijn weekend gewenst.
Hetzelfde, ook een goed weekend.
Ja, dankjewel.
Ja.
Dus,
Hoi, zoiets.
Hey, groetjes. Hoi, hoi.
Octavian, thank you very much.
Yeah.
Thank you.
Have a good day, all of you. Bye.
Okay, thank you. Bye-bye.
Same.
Bye-bye.